Alright guys, today we're going to be covering 7.9 applications of law of sine and law of cosines. So, to get started, we only have a few steps in order to solve these. And if you're not sure how to use law of sine or law of cosine, refer back to the 7.7 video or the 7.8 video. So the steps to solve. The first thing that you need to do for each of these problems is draw a picture. After you draw your picture, and again, it doesn't need to be a right triangle. It can be, but it doesn't need to be, because again, these laws work for any triangle. After you draw your picture, you're then going to determine which law to use, whether it be law of sines or law of cosines. So to determine that, you're going to be looking for things like side, 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 or side, angle, side for law of cosines. And then for law of sines, you're going to be looking for an opposite side, opposite angle pairing, something that where they both have values for those, for the angle and for the opposite side length. Once you determine which one you're going to use, which law you're going to use, you're going to set up your chosen equation. If you're using law of cosines, you'll use law of sines after solving to solve for any missing parts. If it's law of sines, then you're going to continue to use law of sines until you have all your pieces, or you'll use the triangle angle sum theorem, meaning all angles in a triangle equal 180 degrees. You'll do that until you have your final answer. So, we're going to start today off by working with law of sines. Now, it's not always going to be given to you which law we're using when, but I want to make sure that your notes are organized for this at least, so you can refer back to these whenever you need to. So our first question. A baseball pennant is in the shape of an isosceles triangle. The base is 18 inches long. The sides meet at an angle of 32 degrees. How long are the sides? So the first thing that we're going to do here is we're going to draw what's given to us. We know the base is 18. We know that this is isosceles, so the base angles are congruent, as well as the legs are congruent. And then lastly, our vertex angle is 32 degrees. So I can just draw all that information in right away. Now, since I have the vertex angle and the two base angles are congruent, I can solve for the base angles. I can say that both of these are a variable x. So therefore, we would have 180 degrees equals 32 degrees plus x plus x. From there, I'm going to go ahead and subtract 32 from both sides. That'll leave us with 148 equals 2x. And then from there, we'll divide both sides by 2, giving us our final answer for x as 74 degrees. So both these angles are 74. And that's typically what you want to do with law of sines problems first, is see if you can find all the angle measures right away. Now at this point, we're going to start checking for opposite side, opposite angle pairing. I see that we have 32 degrees, and on the opposite side, we have a length of 18. Let me redraw that. 32 degrees, on the opposite side, we have a length of 18. There's an opposite side, opposite angle pairing. And again, we have both values here. They both have numbers. So we want to use that. That means that we can set up law of sines. Now, for our other one, well, I have this x degrees that we just found. We now know that x is 74. And we have the side that we're actually looking for. I'll just go ahead and call that A for now. I could use the other sides as well, but you don't need to. You just need to choose one of them. So at this point, we're going to use law of sines. Again, law of sines is sine of angle A over A equals sine of angle B over B. Plugging in our values, that'll give us sine of 74 over A equals sine of 32 over 18. Now that we have our proportions set up, and on top of that, we only have one variable, we can now solve for A. So I'm going to go ahead and cross multiply, giving me A sine of 32 equals 18 sine of 74. At this point, I only need to get A isolated. Since sine of 32 is a number, it has a value, I'm going to divide both sides by sine of 32. When I do that, the sine of 32 will cancel, leaving me with A is about 32.7 inches. So therefore, if the base is 18, then the length of one of the sides is 32.7. And since this is isosceles, they both are the same length. All right, let's go ahead and move on to our next one. Again, please feel free to pause the video at any time if you need more time, or if you just need to break it down piece by piece. Next up, a fire is sighted from two ranger towers that are 4,000 meters apart. The angles of observation to the fire are 50 degrees from one station and 43 degrees from the other. Find the distance from the closer station to the fire. So, First thing I'm going to do is I'm going to go ahead and draw my two towers and my fire. These are the vertices of my triangle. Once I have them all drawn up, I can go ahead and draw my triangle between all three and label my parts. I know that the towers are 4,000 meters apart. I know that from one tower, it's 50 degrees of observation, and from the other, it's 43 degrees for the observation angle. So we now have all these pieces. Now we're looking for the distance from the closer station to the fire. So to find the closer station, I need to look at the angles. The shorter side is always opposite the smaller angle, and the smallest side is opposite the smallest angle. So my smallest angle here is 43 degrees. Since my smallest side is 43 degrees, that means that my shorter side is right over here. So that's the side that we're going to try and solve for. We're going to go ahead and call that A, little a. So with that, with now knowing that we need to solve for this missing side, I'm next going to find our fire angle. I already have 50 degrees and 43 degrees, so I can solve for this missing angle here. So our fire angle is 180 minus 43 minus 50, which will give us 87 degrees. Well, now that we have 87 degrees there, we can look for those opposite side, opposite angle pairings. Whoops, sorry about that. Let me go ahead and rush through this one more time. That way I can get all those pictures and values up for you. But again, now we should have an opposite side, opposite angle pairing. And if we have that, that means that we can use law of sines. So here we go. I have my opposite side, opposite angle pairing with 4,087. And since they both have values, that's what we want to use. And then we also have opposite side, opposite angle pairing with A and 43. So since we're trying to solve for A, that's what we want to use as well. So now we can use law of sines. Sine of A over A equals sine of B over B. So sine of 43 degrees over A equals sine of 87 degrees over 4,000. From here, I just need to cross multiply and solve. Cross multiplying will give me A times sine of 87 equals 4,000 times sine of 43. Again, our goal is to get A isolated. So at this point, I'd divide both sides by sine of 87, which would leave me with A is equal to 4,000 sine of 43 over sine of 87. When you enter this into your calculator, it will give you your final answer. Just be wary of the parentheses. Make sure that you include them. If you don't, it will throw off your answer. Plugging this into our calculator will give us our final answer of A being about 2,731.7 meters. All right, next up. A loading ramp 6 meters long makes a 24-degree angle with the level ground below it. The ramp is then replaced with a 16-meter long ramp. Find the angle that the new ramp makes with the ground. So first thing I'm going to do is I'm going to draw up my truck, my hot sauce truck. So here's my hot sauce truck. I drew it in two different sections, and that way we can see what it looks like using two different ramps. So for my first ramp, I know that I have a length of 6 meters for the ramp, and that it meets the ground at 24 degrees. On the other ramp, we have a length of 16 meters, and we want to find the missing angle. Now, since these are both the same truck, they will have the same height. So both of those values are the same. We'll just call those H for now. So let's go ahead and fill in what we know. And since this is a right triangle, that opens up right triangle trig, SOHCAHTOA. That opens up SOHCAHTOA for us. So I go ahead and I start by labeling up my triangle. I'm going to go ahead and use the blue triangle over here in order to solve for H. Because once I solve for H over here, well, that height doesn't change. It doesn't change between the truck. So therefore, I'd have H in my red triangle. And if I have the two sides in my red triangle, then I can solve for my missing angle. So let's go ahead and start off with that. I label the sides of the blue triangle. Opposite is H, hypotenuse is 6, and adjacent is blank. Looking at SOHCAHTOA, we only have opposite and hypotenuse, so we're going to use sine. Sine of 24 degrees is equal to opposite H over hypotenuse 6. At this point, if I want to get H by itself, I would just need to multiply by the denominator. Multiply by 6. This will leave me with H is equal to 6 sine of 24 which is about 2.44 meters. So therefore, the height of the truck is about 2.44 meters off the ground. Next, we can go ahead and solve for this missing angle. Again, it's a right triangle, so I can use SOHCAHTOA. So I'm going to label my sides. Opposite is H, 2.44. Hypotenuse is 16, and adjacent is blank. Again, we have opposite and hypotenuse here. If I have opposite and hypotenuse, I want to use sine. So sine of theta is equal to 2.44 opposite over 16 the hypotenuse. Again, we want to get theta by itself, our unknown angle, so I need to get rid of sine. And the only way that I can get rid of sine is through inverses. So I'm going to take the inverse sine, or arc sine, of both sides. Arc sine and sine will cancel, leaving us with just theta equals arc sine of 2.44 over 16. This is what we want to enter into our calculator. And when we do, we get the angle measure of the 16-meter ramp with the ground. And that angle measure is 8.77 degrees. Next up, a botanist wants to measure the height of a tree leaning away from the house. He knows the angle formed between the ground and the tree is 102 degrees. A 30-foot rope is anchored to the bottom of the house and the top of the tree. The rope and the tree make a 15-degree angle. So, let's go ahead and draw this up. We know that our tree is leaning to the side, so it's not perpendicular to the ground. It's kind of leaning at an angle. And then it's tied to a house. It's anchored to a house to make sure that it doesn't just fall over, so that the wind doesn't just take it down. So we have this angle between the rope and the tree as 15 degrees. Further, we know that the length of the rope is 30 feet. That ties it to the ground, to the house rather. And that the tree and the ground intersect at 102 degrees. So it's leaning 102 degrees from the ground. So it's about 12 degrees off from 90-degree angle, right? It's off a bit. So what we want to do first is, of course, we have two angles. So if we have two angles, then why not just solve for our last missing angle right away? That'll make it easier in case we need to use law of sines, which we obviously do. So, solving for this missing angle, I can do 180 degrees throughout the triangle, minus 102 degrees, minus 15 degrees. That will leave us with 63 degrees. Once we have that angle measure, we can go ahead and look for opposite side, opposite angle pairings. Now I see that we have an opposite side, opposite angle pairing with 102 degrees and 30 feet. So they both have values, we want to use that. I also notice that we have h, what we're trying to solve for, and we have the angle that's opposite that length. So that's also what we're going to use. So therefore we can use law of sines. Sine of 102 over 30 is equal to sine of 63 over h. At this point, we can go ahead and cross multiply and solve for our unknown variable h. Cross multiplying will give us 30 sine of 63 equals h sine of 102. Again, our goal is to get h by itself, so I need to get rid of sine of 102. But that's just a number. If you plug that into your calculator, it just gives you a number. So therefore, I'm just going to divide by sine of 102 from both sides. What we do to one side, we must do to the other. This gives us h is equal to 30 sine of 63 over sine of 102. If you enter this into your calculator and you don't forget this parentheses here, you will get the final answer of the height of the tree being about 27.3 feet. And that's our final answer. Next up, we have a challenge problem. So a wire to the top of a telephone pole makes a 67-degree angle with the ground. At a point 20 feet further out from the wire on the other side of the pole, the angle of elevation to the top of the pole is 35 degrees. How long is the wire? So this is a challenge problem. Go ahead and take a few minutes, pause the video, try it out on your own. My hint is to draw a picture. If you ever need to, go ahead and unpause it, watch a little bit, and then you'll be able to catch back up and continue working. So let's go ahead and get started. First thing I'm going to do is I'm going to draw a picture of my telephone pole and the wire going to the ground. So here's my telephone pole and the wires. Now, with this, I know that, first off, the wire makes a 67-degree angle with the ground and the telephone pole. So it reaches out to the telephone pole as well. On top of that, it's an unknown distance from the telephone pole. On the other side of the telephone pole, an equal distance away, plus an additional 20 feet, is another angle of elevation of 35 degrees looking at the top of the telephone pole. So what this created is it created two right triangles for us. We have two right triangles here. So therefore, we can use SOHCAHTOA to solve for these. So I'm going to create a trig ratio for my triangle on the left side and my triangle on the right side. So for my triangle on the left side, I have 67 degrees. Side opposite is h, my adjacent is x, and my hypotenuse is the wire, which is what we're trying to solve. But I don't have anything for the wire right now, so I'm going to ignore it. We're going to ignore the hypotenuse. Over on my other triangle on the right side, I have 35 degrees. Opposite of 35 is h. And then I have my adjacent as x plus 20. I don't have my hypotenuse again. So since both of these have opposite and adjacent, I'm going to go ahead and use tangent. So tangent of 67 degrees equals opposite h over adjacent x. And tangent of 35 degrees equals opposite h over adjacent x plus 20. From here, I'm going to solve both of these problems for the variable h. To do that, I multiply both of these problems by the denominator. So the blue equation I'll multiply by x. The green equation, I'll multiply both sides by x plus 20. This will leave me with x tangent of 67 equals h, and h is equal to x plus 20 tangent of 35. Now we notice that they're both equal to the same thing. They're both equal to h. So therefore I can use substitution to substitute in for the variable h. This will give me x tangent of 67 degrees equals x plus 20 times tangent of 35. Now, at this point, I'm going to go ahead and do tangent of 67 on the calculator and put it right next to the x. That way we can kind of see the values, because I want to make sure that we're noticing values in like terms as we go through the rest of this. On the right side of my equation, I'm going to distribute tangent of 35 through the parentheses. This will leave me with 2.3559x on the left equals x tangent of 35 plus 20 tangent of 35 on the right side. At this point, I'm just going to go ahead and do tangent of 35 and 20 tangent of 35 on the calculator so I can have some values here. And that way I can combine like terms a little bit easier. So this will give me, again, I just bring down the 2.3559x. Then on the right side, I now have 0.7002x plus 14.0042. I got these from tangent of 35 is 0.7002, and 20 tangent of 35 is 14.0042. At this point, I'm going to go ahead and move my x values all to one side of my equation by subtracting 0.7002x from both sides. This will leave me with 1.6556x equals 14.0042. At this point, I go ahead and I divide both sides by 1.6556, and that will leave me with my final answer for the distance from the telephone pole as 8.4584. But that's not what we're trying to solve for. We're trying to solve for the length of the wire. So we're trying to solve for this hypotenuse over here. Well, now that I have this x value, I should be able to solve for the hypotenuse using right triangle trig. So therefore, I'm going to go ahead and go back to this triangle here. And this time I'm going to try and solve for w, my wire. So opposite is still h, adjacent is still x, and hypotenuse is still the wire. This time, since we have hypotenuse and adjacent, we'll use cosine. Cosine of 67 degrees equals adjacent 8.4584 over w, the hypotenuse, the wire. If you guys recall the little trick, if I have my denominator here as my variable, I can go ahead and switch what's on the other side of the equal sign and my denominator. So this will actually turn into w is equal to 8.4584 over cosine of 67. If you enter that into your calculator, you'll get the final answer as 21.6 feet, which is the length of the wire. All right, that is it for law of sines. Next up, we're moving on to law of cosines. So our first problem with law of cosines is a piece of wire is 6.2 feet long. It is bent into a triangular shape. One side is 1.7 feet long. The other is 2.4 feet long. Find the angles of the triangle. So to begin, I'm going to go ahead and find out our missing side length. I know the full distance is 6.2, and I already have two sides. So if I subtract these two sides from 6.2, I'll have our remaining side, which will give us BC, which is equal to 2.1. Now that we have all three sides, that's a clear indicator that we're going to use law of cosines. Now I want to find my largest angle first, which would be angle B. I know that's my largest angle because it's opposite the largest side length. So solving for B, I'm going to have B squared 2.4 equals A squared 1.7 plus C squared 2.1 minus 2 times A 1.7 times B 2.1 cosine of angle B. From here, we're just going to go ahead and do the calculations on our calculators to try and simplify this a little bit. So we'll give us 5.76 equals 2.89 plus 4.41 minus 7.14 cosine of angle B. If I combine the blue and the greenish, 2.89 plus 4.41, that'll give us 7.3. From here, I'm going to subtract 7.3 from both sides because, again, I want to get cosine of angle B by itself. And that will leave me with negative 1.54 equals negative 7.14 cosine of angle B. Lastly, I divide both sides by negative 7.14 to get cosine of angle B by itself. That would leave me with cosine of angle B equals 1.54 over 7.14. Again, a negative divided by a negative is always a positive. Now, I need to get cosine away from angle B. The only way that I can get rid of cosine is through inverse. So I'm going to use the arc cosine. I take the arc cosine of both sides. That'll give us angle B is equal to the arc cosine of 1.54 over 7.14, which is about 77.5 degrees. And again, this is what you'd be wanting to enter into your calculator. At this point, now that I have an opposite side, opposite angle pair, we can go ahead and use law of sines to find our next angle, which I'm going to go ahead and use to find out angle C. So therefore, I'm going to use law of sines. Sine of 77.5 over 2.4 equals sine of angle C over 1.7. Cross multiplying will give me 2.4 times sine of C equals 1.7 times sine of 77.5. I want to get C by itself, so I'm going to go ahead and divide both sides by 2.4. That'll leave me with sine of angle C equals 1.7 sine of 77.5 over 2.4. Next, I need to get rid of sine. Again, we want C by itself. The only way to get rid of a trig function is through the inverse trig function. So I take the arc sine of both sides. Sine and arc sine will cancel, leaving me with angle C equals the arc sine of 1.7 sine of 77.5 over 2.4. This is what you want to enter into your calculator. Please do not forget your parentheses. That will throw everything off if you forget those. If you enter this into your calculator correctly, it will give you your final answer for angle C as 43.8 degrees. Now that we have angle B and angle C, we can find out what angle A is. We're going to use the triangle angle sum theorem for this. That way we don't need to do more work of law of sines again. So we know that there's 180 degrees in the triangle. So I have 180 minus 77.5 minus 43.8. If we enter that into our calculator, it'll give us angle A, which is 58.7 degrees. So we now have all of our angles and all of our sides. Next up, plane A has been flying for an hour and a half at 400 miles per hour, heading 130 degrees from Phoenix Sky Harbor Airport. Plane B has been flying for 1 hour at 350 miles per hour, heading 150 degrees from the airport. How far apart are the planes? So first thing I'm going to do is I'm going to actually find out how far they've traveled. So plane A was traveling at 400 miles per hour, and they traveled for 1.5 hours at that speed, for an hour and a half. So therefore I have 400 miles per 1 hour times 1.5 hours. With this dimensional analysis, the hours will cancel, and I'll just be left with miles. 400 times 1.5 will give me 600 miles. As for plane B, well, they've only traveled 1 hour at 350 miles per hour, which means they've only traveled 350 miles. So, what this means is that I have my airport here, Phoenix Sky Harbor, and this plane took off at 130 degrees away from the airport, traveling 600 miles so far. The other plane traveled left the airport at a 150 degree angle away from it, and it's traveled 350 miles, which means that the angle in between is just 20 degrees. Now, we're going to go ahead and solve for this distance between the two planes. That's our x value. And since we have side, angle, side, that means that we're going to use law of cosines. That's our big indicator as well. So therefore, we're going to have x squared equals 350 squared plus 600 squared minus 2 times 350 times 600 cosine of 20 degrees. So again, this is just law of cosines using x and angle of 20 degrees here. From here, since I'm solving for the side length, I can enter this entire string onto my calculator. Just make sure that you have your parentheses and make sure that you enter it in correctly. Double check it. If you enter it incorrectly, you should be given x squared is equal to 87,829.09927. Again, this is x squared. So to get rid of the square, we must take the square root of both sides. If we take the square root of both sides, we'll be left with x is about 296 miles apart. So that's how far apart the planes are. They're almost 300 miles apart from each other. All right, and our final question of the video. When driving from Phoenix to Tucson, Albert will drive 100 miles, stopping in Tucson and then heading northeast at a 110 degree angle from his previous path for 400 miles will get him to El Paso. What is the distance from Phoenix to El Paso, and what is the angle formed between Phoenix, Tucson, and Phoenix, El Paso? So, to get started on this, first thing that we're going to do is we're going to go ahead and draw up our triangle. We're going to drop our triangle with the three cities, Phoenix, Tucson, and El Paso. So, doing so, first off, for Phoenix to Tucson, he traveled 100 miles. So there's Phoenix, there's Tucson, traveled 100 miles to get there. He then turned northeast at a 110 degree angle, and this is not going to be drawn to scale, so if you're like, your triangle looks weird, it's fine. Travels at a 110 degree angle northeast to get to El Paso. He traveled 400 miles along that route. Lastly, we want to know the distance from Phoenix to El Paso, so we'll call that x. You also want the two angle measures here, which we'll find in just a minute. So, looking at this, I want to solve for x to get started. And since we're solving for x, we're going to use the law of cosines, because I have side, angle, side. Since we have side, angle, side, that means use law of cosines. So that'll give us x squared equals 400 squared plus 100 squared minus 2 times 400 times 100, cosine of 110 degrees. Again, since we're finding the side length, you can enter this entire thing on your calculator, parentheses and all, and it'll give you x squared is equal to 197,361.6115. If you get rid of the square by taking the square root of both sides, you'll be left with x is about 444 miles. So from Phoenix to El Paso is 444 miles. Now that we have our distance, we want to find our angle measure next. And to do that, we're going to use law of sines. So we look for opposite side, opposite angle pairings. I see that we have a couple of them. So circling those up, that would give me sine of 110 degrees over 444 equals sine of theta over 400. Let me go ahead and change these colors real quick. So here's my red, and then here's my blue. That way we don't get them mixed up. From here, we can cross multiply to solve. This will give us 400 sine of 110 degrees equals 444 sine of theta. To get theta by itself, we're going to go ahead and divide both sides by 444, leaving us with sine of theta equals 400 sine of 110 degrees over 444. Lastly, we need to get rid of sine. To do that, we take the arc sine of both sides. Taking the arc sine will give me theta is about 57.8 degrees. Again, this is what you want to enter into your calculator. Please be careful with your parentheses when you enter it in. Now that I have 57.8 degrees for theta, I'm going to go ahead and find our final angle measure down below. To do that, I can just do 180 degrees, the total amount in a triangle, minus 110 degrees plus 57.8 degrees. I'm going to combine these first and then subtract it. You can just continue subtracting from 180. That should be fine as well. Entering that into your calculator will give you your missing angle as equal to 12.2 degrees. And that's our final answer. All right, guys, thank you so much for watching today. If you have any questions, please feel free to reach